point of care testing. Okay, so I will just share my slide to you so that we can already start. Or the slide is not moving. If there are any Okay, so class reminder, if there are any technical problems such as no audio or the slide is not moving, just call my attention so that we can fix the problem. Okay, so I think we can already start. There you go. So you have instrumentation. Now, what's the importance or what's the relevance of this uh, topic to your future profession? Now, we all know that your analytic techniques and the different instruments provide the foundation for all measurements. So we will need them. No, we will need this analytic techniques and instrumentation in order for us to produce a laboratory result. Okay, so we have different instruments used in clinical chemistry. Some of them you have might encounter them already during your internship. No, so some of you have already operated some of these instruments. No, okay. So when it comes to instrumentation, it will fall into one of four basic disciplines within the field of your analytic chemistry. So you have the following: spectrometry, luminescence, electroanalytic, and chromatography. Okay. Um, so you have your spectrometry, your spectrophotometer, the most basic instrument used in clinical chemistry for uh, assays. Then you have your luminescence, okay, light emission, okay, fluorescence, electroanalytic, combination of your electricity and you have your chemical, okay, electrochemical, and then you have your chromatography, separation of compounds in the mixture. Okay, so that's an example. Okay, so we will go on to them one by one. No, so we will now proceed with your photometric techniques. So we will start with the most basic one, which is you have your spectrophotometry. And okay, so what will be the flow of our discussion? So first, we're going to discuss the principle, okay, and then what are the components inside the instrument and what are their uses. We will even talk about the different types of these instruments, okay. And so principle, you have your spectrophotometry. Okay, so principle, it measures the array of lights or radiant energy absorbed or transmitted. So you have the light here, right? So light, or you can also call it as your radiant energy being absorbed or transmitted. Okay, so let's try to look at this one, lights or radiant energy. What are the basic concepts when it comes to your lights or radiant energy? Okay, so basic concepts of light. Okay, now your light or light energy exists as a wave. Okay, so exists as a wave. You have it here. So magnetic field. Oh, and then you have your electric field. Okay, so magnetic field, then you have your electric field, which exists as a wave. Now, this light energy is oscillating. Okay, so it's oscillating. Ayan. So light energy is a form of electromagnetic radiation. Okay. Um, or electromagnetic radiation is an electric and magnetic disturbance traveling through your space at the speed of light. Okay. You can call them photons. Okay. Ayan. Okay, so since it exists as a wave, let us try to look at a wave view. Yan. So we have your frequency. So frequency is the number of vibrations of wave per second. So you have your high frequency and you have your low frequency. Then you have wavelength. This is the distance between two successive peaks. Okay, so you have your frequency and number of vibrations per second. Yan. So if it's a high frequency, there will be increased number of vibrations per second. If it's a low frequency, okay, less vibrations per second. Then you have your wavelength, distance between two successive peaks. If this is the wave, you can see now that you have the peaks. So wavelength is the distance between the two peaks. Okay, and two peaks. Right. So let's try to analyze this one. If there is a high frequency light wave, then what will be the wavelength? Okay, so wavelength is the distance between two peaks. Okay. Meron na bang gusto mag-recite dyan? So increased frequency means what will be the wavelength? Okay. There's increased frequency, so increased vibrations of the wave, okay, per second. Now, what will be the wavelength? Wala pang gusto mag-recite. No, nahiya pa. Okay. So if there's a high frequency, okay, more vibrations, therefore, there will be reduced distance of the peaks. Therefore, if there is increased frequency, there will be shorter wavelengths. Pwede natin baliktarin. So if there will be low frequency or less frequency, there will be less vibrations, less wave produced. Okay, so that's low frequency. Then there will be a increased distance between the peaks of the wave. So here you can see now that compared to the high frequency wave, if you have less frequency, okay, the distance between the peaks will increase. Therefore, if there is decreased frequency, you will have a longer wavelength. And okay, now we can also relate your frequency with your energy. If there is a higher frequency, then that means that light has a higher energy or greater energy. So ano yung mga pwede nating ma-establish na relationship dito? Frequency and wavelength is inverse, while frequency and energy is directly proportional. Okay? Now, let's take a look at electromagnetic spectrum. Okay, so light exists in different wavelengths. Okay, now when it comes to your wavelengths, we have a region wherein you have the visible light. This is the light that can be seen by the eyes. Okay, and so electromagnetic radiation includes radiant energy that extends from the cosmic rays. Okay, with wavelengths as short as 10 raised to negative 9 nanometers up to radio waves greater than 1,000 kilometers. Imagine that, no? Very long wavelength. But let's focus on the term light used to describe radiant energy from ultraviolet to the visible portions of the spectrum. Okay, so yan, since nasa clinical chemistry tayo, tingnan lang natin yung light as yung sa ultraviolet hanggang doon sa may visible light. Okay, so that's about 290 to 750 nanometers or shown by this table. Yan. Okay, so yung ultraviolet, ang wavelength niya is less than 380 nanometers. Okay, so observe it's invisible, we cannot see it. Then you have the visible region of the wavelength, you have your 380 to 440. Yan, ito yung mga nakikita natin. And the observed colors, you have the following. You have your violet, yung rainbow colors, violet, blue, green, yellow, orange, red. Now, if we have longer wavelengths, yung mga near infrared, mid infrared, this is already not visible. Okay, so this table shows the approximate relationship between wavelengths and the color characteristics or color depicted for the UV, the visible, and the short infrared portions of the spectrum. Okay, so please take note, class, that the wavelength intervals are only approximation. So owing to the subjective nature of your color. Okay, so we already know the basic concepts of your light. So first is that light exists as a wave. So you have your wave, you have your electric field, and you have your magnetic field, and it is oscillating. Now we can differentiate the wave based on the frequency. So you have your high frequency or low frequency, and you have your wavelength, right? And then we have already established that your frequency is inversely proportional to your wavelength. Then, another relationship, your frequency is directly proportional to your energy. Okay, next. Spectrophotometry will be based on the following. You should have a chemical reaction. Okay, so what is this chemical reaction? Okay, now in testing, no, or in performing a test in clinical chemistry, okay, for example, the physician wants the measurement of this analyte. Okay, you will need your reagent. So in your reagent, you have different chemical substances that will react with your analyte. Now, how will you initiate the chemical reaction? It's simple. You're going to add your sample into your reagent, which will now produce a chemical reaction. So in the sample, you have your analyte. Then here you have your reagent. How will you initiate the chemical reaction? So the analyte of interest, okay, or the sample containing the analyte of interest will be added to your reagent so that it will have a chemical reaction. Okay. And we have different types of reagents. Okay, so in your reagents, it could contain enzymes or chemical agents that will react to your analyte. Okay, so that's your chemical reaction. And now, through that chemical reaction, it will produce a colored product or colored substance that absorbs light. So a substance. So let's go back to the diagram. No, analyte. You have the reagent. You have the analyte. The analyte or the sample will be added to your reagent. Now, the analyte will react with your reagent, forming now your colored product, or you have your colored substance. And so it will be based on the following. Okay, so first there will be a chemical reaction through the addition of your sample into your reagent, which will now produce a colored product or colored substance. Now, this colored substance will absorb light, but it will not automatically absorb light. It should be in specific wavelength. So we have discussed wavelength earlier, right? Okay. So the spectrophotometer should be set in the specific wavelength so that the colored product can absorb light. And so specific wavelength. Okay, sir, why do we need to set this wavelength? Because the selected wavelength highlighted in the rainbow color will be absorbed by the colored product. Okay, saan nanggaling yung colored product? This colored product was produced from the reaction. Diba? Okay, so for example, our colored product or the colored product produced from the chemical reaction is violet. Okay, now how would we know, okay, what wavelength or what color of light will be absorbed by this colored product? Okay, paano natin malalaman kung anong kulay ng light ang ma-absorb ng colored product? Now, this will be based on your colors. So, let's just make it simple. Do not forget your color circle. Kung ano yung complementary nung colored product, yun yung i-absorb niya. So, ang color natin is violet, right? Okay, so ang violet, if the colored product is colored violet, ang i-absorb niya is, tingnan nyo lang yung complementary. You have your yellow or you have your green. Tingnan natin sa table na to. Natin kung tama. So, you have the color of your colored product. Ayan. So, ang colored product natin is violet. Ang i-absorb niya is yellowish green. So, anong wavelength ng yellowish green? You have 560 to 580. O, yan. Dapat, tama yung wavelength para yung colored product ma-absorb niya yung selected wavelength. Okay. Natin tong case na to. Okay, so this is for the determination of your albumin. So, the principle, based on the specific binding of your BCG and the protein at acidic pH to produce a color change of the indicator from yellow-green to green-blue complex. Okay, so what is the color of your colored product? from the chemical reaction. You have your greenish blue or blue-green complex. Tinakpan ko yan para may challenge. Okay. So, ano kaya ang kulay ng light ang i-absorb nitong greenish blue or bluish green complex? Paano natin malalaman? Tingnan niyo yung color wheel ulit. Okay. Kung greenish blue, so ayan, ang i-absorb ng light is you have your red. And ano ang wavelength ng red? You have sa 700 nanometers. So, tignan natin kung tama tayo. So, greenish blue, ang wavelength niya is nasa 650 or bluish green, nasa 650 to 780. Tingnan natin kung tama tayo. Dapat red to. Tignan nyo. Tama, di ba? It's color red. So, bluish green, tingnan nyo yung complementary color, which is red. Ang wavelength ng red light is you have your 650 to 780 nanometers. Okay, so I hope you have understand this one. Okay, so chemical reaction. You already know the colored product. The colored product can absorb light at a specific wavelength. Okay, so you should know what will be the right wavelength. Okay, next, it will be based on your Beer-Lambert's law, wherein it states that the concentration of the substance or the concentration of the analyte or the concentration of the biochemical substance you are trying to measure is equal to the amount of light absorbed of the solution, amount of light absorbed by the solution, or the logarithm of transmitted light. Okay. So this can be best shown by this graph. As the concentration of the analyte increases, the absorbance also increases. Right? Baliktaran naman siya no transmittance. Okay? As the concentration of the analyte increases, that percent transmittance decreases. So you have a decreasing concentration. I mean, a decreasing value of your transmittance as the concentration increases. Okay, so tingnan natin to equation to. Take a logic out of this Beer's law. No? If there is increased concentration of the analyte, it means that more or less colored substance will be produced. Okay, pwede na siguro kayo mag-recite. Tatawagin ko kayo. Hindi ko pwedeng escape kasi makikita niyo yung sagot. Anyone? Anyone from the class? Okay. If there will be increased concentration of the analyte, it means that there will be more colored substance produced. Okay. More analyte that will react with the reagent. Therefore, mas maraming colored substance ang mapoproduce. Therefore, ano mangyayari? Mas maraming light ang ma-absorb. Therefore, you have increased absorbance. Right? Now, i-adapt natin to sa performance of test. For example, yung physician nag-request ng creatinine determination. Okay, so you're going to determine the concentration of creatinine in the sample of the patient. Then you have the principle here. Let's try to take or read the principle. So in the Jaffe reaction, creatinine reacts with your picric acid under alkaline conditions. So creatinine in the sample will react with your reagent, which is your picric acid. So this is your chemical reaction. Now, what will be produced? So in every reaction, you will have a colored product. So what will be the colored product of this reaction? You have your red colored product. Okay. Now this red colored product can absorb light at 510 nanometers. So this is the specific wavelength. Okay. So gets nyo? Yung creatinine sa sample, in-add mo sa picric acid, nag-produce ng red colored product. And this red colored product absorbs light at 510 nanometers. Itong 510 nanometers, yung kulay ng light dito nasa color blue. Okay. Okay. So this is your picric acid. Yung picric acid color yellow. Imagine natin na ganito, no? Yan, so lapit tayo. So this is just a graphical representation so that you can appreciate this. No? So in your sample, and dito yung pipette tip natin. Andyan yung sample nyo. Now in your sample, you have different analytes, right? But let's focus on your creatinine. So you're going to dispense this into your reagent, which is your picric acid. So creatinine, so mag-first stop ka sa pipetting, di ba? Tapos pipindutin mo yung second stop. Now, pagkapindot ng second stop, madi-dispense na yung sample. Now, the creatinine in the sample will react with your picric acid, forming now a red-colored complex. Yan. Okay. First, if there is the formation of your colored product, you will also notice the change in the color of your solution. Let's try to analyze. So, creatinine na analyte nandun sa may sample natin. Inad natin sa dun sa may picric acid. So if there is increased creatinine in the sample, it is expected that there will be more red-colored product produced. Therefore, mas mataas yung absorbance or mas madami yung ma-absorb na light. Another one, albumin naman tayo. So for example, pinapa-measure nung physician yung albumin concentration nung yung albumin concentration doon sa sample. Right? So you have your albumin, inad mo doon sa reagent. What will be our reagent? Bromcresol green. So this will be the chemical reaction. So take note of the pH. It's acidic. What will be the colored product? You have your green-blue complex. Okay. So ano kaya ang color ng light? Parang ito din ang example natin kanina. So you have your green-blue complex or bluish-green complex. Now, what will be the color of the light na ma-absorb ng green-blue complex natin? You have your red. So, parang ganito din yan, di ba? You have your reagent here, your bromcresol green. Ayan. You have your pipette tip. Sa sample mo, nandoon yung analyte natin, albumin. So, albumin, first step, second step, dispense mo yung sample. Then, albumin reacts with your bromcresol green, forming a BCG complex or your greenish-blue or blue-green complex. Color of your solution. Okay. So, analyze natin. Kung mas maraming albumin doon sa sample, ibig sabihin, mas maraming blue-green complex ang maproproduce, leading to increased absorbance. Okay. Yan. That's not it. We need to go into your Beer's law, no? Deeper understanding of your Beer's law. Ano ba itong Beer's law na to? So, sabi kanina, the concentration of the substance will be equal to the absorbance or logarithm of transmitted light. Pero tingnan natin to. Ito mas detalyado. So, you listen very carefully. Okay? So, Beer's law equation relates the amount of analyte in a sample to the absorption of light passing through it. Now, we can express your Beer's law as A is equal to epsilon. Then you have BC. Well, where A stands for absorbance, epsilon will be for molar absorptivity. So measures of how well a chemical species absorbs a given wavelength of light. And ito yung example, no? So ito yung analyte, ito yung method, ito yung colored product na maproproduce. So glucose, under the principle of oxidase, will produce a red quinolamine dye. Now, the molar absorptivity of your red quinolamine dye is 6.58. Paano naman pag acid phosphatase? Using the method of Roy and Hillman, the colored product will be p-nitrophenol. Ang molar absorptivity ng p-nitrophenol is 18.3. And then, B will be the path length, kung gaano haba yung dadaanan ng light. Okay, so if this is your cuvette, path length natin is here, the length of your cuvette. Now, it has been standardized that the length of the cuvette will be 1 centimeter. Yan. So, the longer the length of the light path, the more light will be absorbed. Okay. Kung mas marami or mas mahaba yung path niya, mas maraming pagdadaanan, mas maraming ma-absorb na light. And C stands for your concentration. Now, we could use this equation for us to compute for the concentration of the analyte. Ito muna tayo sa absorbance. Nangyari dito. You have the light here that will pass through your solution. Now, here, the light or the absorbance will happen. Okay. Wait lang. Okay. Now, the intensity of the light before it passes through the solution is different from the intensity of the light after it passes the solution. Okay, so we could label this as I0. Ibig sabihin, bakit 0? Wala pang light ang na-absorb. So, intensity of the light as it enters the sample. Ito namang light dito, we could label it as capital I only. So, intensity of the light as it leaves the sample. So, para hindi nyo makalimutan, itong light na to, before it passes the solution, you can tag it as I0. Bakit 0? Wala pang na-absorb na light. Okay. Ito naman, may na-absorb na light. So, the intensity is different. Mas lakas yung intensity dito compared dito. Kasi dito, meron ng light na na-absorb. Okay. So, based on the equation, A is equal to log of your I0 divided by your I. So, pwede nating baliktarin yan. Being absorbance is equal to negative log, tas magbabaliktad siya. I divided by your I0. This one, pwede nating ipalit dito. Substitute natin. O, yan. Meron tayong equation na based on this equation, pwede nating makompute yung concentration as long as given yung intensity. Okay. Let us apply. Okay. Now, the concentration of the solution is unknown, but we have the given. Ayan. So, A is equal to epsilon, B and C, and A is equal to log. Then you have your I0 divided by I. Pwede natin makompute yung concentration dito. Unahin natin itong equation na to. Absorbance is equal to log. Then, yung I0 naging 1. Sir, bakit 1? 1 stands for your 100%. Okay. So, kasi wala pang na-absorb na light dyan, no? And then, yung I natin, ibig sabihin ito, dumaan na sa solution is 0.12. So, ano ang absorbance natin? A is equal to 0.9208. You could bring out your calculators or you could get your calculators para makasabay kayo sa computation. Ayan. And di pa tayo tapos kasi our objective is to compute for the concentration. So, kulang to. Now, we could use this other equation. A is equal to epsilon B and C. Ayan. So, we could derive, for us to get the concentration, pwede nating i-manipulate tong equation na to. Naging ganito siya. Concentration will be equal to, tapos nasa baba, nasa denominator si epsilon, saka yung B, yung light path. From this one, pwede natin makompute yung computation by manipulating the formula. Ayan. So, C is equal to A divided by epsilon B. So, pwede na natin i-substitute. So, nakuha na natin yung absorbance kanina. That will be 0.9208. And then, i-substitute lang natin. Yung molar absorptivity, yung epsilon is 0.35. And then, you have your B, which is 2 centimeters. So, yan. Pwede na natin makompute yung concentration ng solution natin. And that will be 1.3 molar. Kuha. Balikan natin para hindi kayo malito. Now, we could use the two equations. Sabi ko nila, we could use the two equations for us to compute for the concentration of the solution. So how did we do this? Yan. So absorbance, ito muna yung unahin nyo, log I0 divided by I. So log. Sir, bakit naging 1 yung I0? Kasi nga 100%. No? Wala pa kang nangyayaring light absorbing sa light na to. No? And then you have your 12. Yun na yung I natin. Okay? So that will be 0.9208. But we're not done yet because our objective is to get or to obtain the concentration. So how are we going to do that? We could combine these two equations. So ito muna, A is equal to epsilon or molar absorptivity, light path, and concentration. So i-derive natin, concentration will be equal to, then yung molar absorptivity and light path nasa denominator, tapos then just substitute, then lalabas na yung result natin. Okay, so ano natutunan natin dito? Based on the equation of your Beer's law, we can obtain the concentration of your solution as long as there is a given. So yung I, saka si light path, saka yung molar absorptivity. And punta naman tayo sa transmittance. Okay, so when you say transmittance, ito na yung light na nakatakas. Ibig sabihin, hindi na-absorb nung ating colored product. A fraction amount of light that successfully passes to the substance without being absorbed. Okay. So for the formula of your transmittance, that will be your I divided by your I0. Wait a minute. Nakita nyo itong equation na to? Parang siya din yung kanina, di ba? O, tignan nyo. A is equal to negative log divided by I times 0. So, pwede nating i-substitute yan. Magiging ganito. A is equal to negative log transmittance. So, pwede nating makuha yung absorbance using this formula. Okay, let us apply. Okay. Kuha na kayo ng calcu para makapag-compute tayo. Let us apply. The intensity of the incident light on a sample is 0.50 and the intensity of light entering the detector is 0.36. Okay, now what is the transmittance and absorbance? Okay, so ito yung formula na nakuha natin kanina. Transmittance is equal to I divided by your I0. So ano yung I natin? Okay, so light entering the detector. Okay, malilito. Light entering the detector, ito yung transmitted light. Kasi papunta na siya doon sa may photodetector natin. Then, divided by your I0, incident light. Hindi niya pa nadaanan yung sample or yung solution. And that will be 0.72. So, ibig sabihin yan, so 100%. Ayun, ano ang ilan yung percent nung na-transmit na light? Ito siya. That will be 72%. So, 28% yung na-absorb na light dun sa may solution natin. Okay, now, tingnan natin dito sa absorbance. So, absorbance is equal to negative log of your transmittance. So, substitute lang natin. Negative log of your 0.72 transmittance will be equal to 0.14 7. Sir, bakit hindi tugma? Di ba dapat 28% yan? Now, class, remember, we have other factors to consider pag dumaan dito yung light natin. So, what are the different factors? Now, hindi naman lahat ng light na dumadaan dyan is na-absorb. Some is being reflected or deflected. Kaya siguro ito yung result ng absorbance natin. So, that's how you're going to compute for transmittance and absorbance. Okay, transmittance versus absorbance. Okay, we will establish the relationship between your transmittance and your absorbance by computation. So, anyway, share ko naman yung PowerPoint sa inyo, kayo nang mag-compute. Pag 100% transmittance, ibig sabihin, walang light ang na-absorb ng solution natin. Okay, tapos, yan. Okay, so what did you notice? Less transmittance will lead to greater absorbance. So absorbance has an inverse relationship with your transmittance. Pag mas maraming light ang na-absorb, less yung matatransmit. Pag mas maraming or pag mas less yung light na na-absorb, mas maraming light ang matatransmit. Okay, so that's the application of your Beer's law. Anong natutunan natin doon? So you have two equations that can be combined for us to compute for the concentration, and we also have learned the computation for your absorbance and transmittance. As long as kompleto yung given natin, such as your molar absorptivity, value of your transmitted light, or value of your I0, and or yung incident light natin. Okay, now we cannot fully understand spectrophotometer if we will not explore what's inside the spectrophotometer. So, ito, titignan natin yung components. How does the spectrophotometer work? So, we can determine that by knowing the different components of your spectrophotometer. Ito siya. Right? Balikan natin yung principle. Spectrophotometry measures the array of light or radiant energy being absorbed or transmitted. That's why you have your light source. Right? So, isa-isayin natin. Okay, so light source. Source of light. And then you have it here, entrance slit. Okay, so you have a opening there. That's your slit. What's the purpose of your entrance slit? The entrance slit will prevent the entry of your stray light. When you say stray light, okay, so itong entrance slit na tayo. When you say stray light, this is the unwanted light. Another purpose of your entrance slit is to focus the light coming from your light source para pumunta doon sa ating monochromator. Okay, next you have your monochromator. Your monochromator will isolate the specific wavelength. Okay. In order for the colored product to absorb a specific wavelength, kailangan i-isolate yan no monochromator natin. Okay, so monochromator isolates the specific wavelength. Then you have your exit slit. The exit slit will only allow the entry of the isolated wavelength. So parang si entrance slit then, so entrance slit prevents the entry of your stray light. Sa exit slit, it will only let the isolated wavelength to pass through the sample or to the solution. Okay? Have your cuvette, or you also call it as your sample cell. Maraming pangalan yan. Cuvette, sample cell, or analytical cell. It's holding the solution, no? Yung binabasa mong solution. Then you have your photodetector. Okay? The purpose of this photodetector, in order for us to have a reading, okay, this photodetector will convert that transmitted light from light energy into electrical energy so that we can have a readable output. So it goes like this, right? So i-on mo yung spectrophotometer mo. So you have your light source. Now the light will pass to your entrance slit. Okay, so entrance slit will prevent the entry of your stray light. This will now pass to your monochromator. Now, kita niyo sa taas, dyan yung knob, di ba? Pag in-adjust mo yung knob, iikot yung prism or yung monochromator para ma-isolate natin yung specific wavelength. So wavelength, okay, so monochromator will isolate the specific wavelength, okay, na dadaan dun sa may exit slit. Of course, do not forget, ito na yung isolated wavelength. Siyempre, wag mong kalimutan yung cuvette mo. Kailangan pasok mo siya dun sa may cuvette well para madaanan yung solution, madaanan nung isolated wavelength natin. So, imagine na, light source, daan sa entrance slit. Entrance slit prevents the entry of your stray light. Monochromator will isolate that specific wavelength, which will now pass to your solution. Okay. So here, ano nangyayari dito? Some of the light will be absorbed, and then some of the light will be transmitted. So imagine the relationship between the two. Okay. More light will be absorbed, less light will be transmitted. More transmitted light means less light is absorbed. So that's the principle, the different components of your spectrophotometer and their different functions. Okay. And of course, pag nakadaan na sa photodetector yung transmitted light, we can already have the reading. So that could be absorbance or that could be percent transmittance. Okay. Side view yon. Sige, tingnan natin. Let's have another activity. Let's see if you can recall the different components in order and try to recall their functions. So, pinakauna si light source. Right? Yun ang inspector nag-on si light source. Then, followed by, baka may pwede nang mag-recite dyan. Sino gusto mag-recite? Come on, guys. This is a fun activity. Hello? Hello? Wala pa rin talaga. Okay. Sige. This will be followed by your entrance slit. Right? Ang pinadaan lang ni entrance slit is yung it prevents the entry of your stray light. Then you have your monochromator. Monochromator isolates the specific wavelength. Bakit kailangan specific wavelength? Based on the principle, para maka-absorb ng light yung na-produce na colored product from the chemical reaction. And you have your exit slit. Then dadaan na siya dun sa may solution, dun sa may cuvette. Okay, so here, some of the light will be absorbed by your colored product and some of the light will be transmitted. Now, the transmitted light pass to your photodetector. Okay. Yan, diba? Dali lang intindihin. Okay. Did you know that dun sa components ng spectrophotometer, it has different types. Now, why do we need to discuss it? Because for each type, meron mga advantages at saka disadvantages. Not only that, it also has its specific uses. Okay, so tignan natin yung mga different types of your light sources. So you have your incandescent lamps, like your tungsten, deuterium, hydrogen, mercury arc lamp, xenon lamp. Let's try to look at their unique characteristics. So tungsten, this is the, sorry, nagbabibrate yung earphones ko. Okay, I headphones. Wait lang. So tungsten, okay, most common light source used for reading absorbance in the visible region or near infrared region. So it has two forms. You have your tungsten iodide and your incandescent tungsten. Next, you have your deuterium discharge lamp. Okay, we use your deuterium discharge lamp if we're going to need or we're going to measure the absorbance in the UV region. You have your hydrogen lamp. So, just like your deuterium, we can also use your hydrogen lamp in measuring absorbance in the UV region. Although we have a problem with your hydrogen lamp, it's less stable and has a shorter life than your deuterium discharge lamp. Mercury arc lamp. Anong unique sa mercury arc lamp? So it is also used in measuring absorbance in the UV region and it has three forms. Si low pressure, medium pressure, at saka high pressure mercury arc lamp. Let us try to differentiate the three. Pag low pressure mercury arc lamp, it will emit a sharp line for UV and visible region. Now, if this is your lamp, no, it is used for calibration purposes only, not practical for absorbance measurements. Medium and high pressure mercury arc lamp, we use it if we're going to read the absorbance, okay, doon sa continuum from UV to mid visible region. So this is a picture of your high pressure mercury vapor lamp, 1936 pa. Ayan, no. So may mga parts din siya, yung electrode, yung evacuation bubble, main electrode, solid mercury residue, fused quartz arc tube, carbon resistor. Ayan. Then you have your xenon measurement, used in measuring absorbance in the UV region also. Ayan. Okay, so those are the different types of your light source. Now let us proceed with the monochromators. Again, just to recall, your monochromator isolates the specific wavelength of light. So how is that possible? Now when it comes to your monochromator, it also has different types. The first one is you have your interference filter. Works under the principle of constructive interference. So it will cancel out undesired wavelengths. So how is that possible? Okay, how is that possible? Punta muna tayo sa may parts. Okay, punta tayo sa may parts. And so you have a semi-reflective coating in the middle. Itong dalawang to, mukhang poste, that is your mirroring each other, no? Ito yung incident light na nanggaling dun sa my light source. So anong ginagawa dito? Ini-split niya para ma-isolate natin yung desired wavelength natin. So a portion will be reflected, tapos a portion will pass through the glass. Yan. So ito yung isolated wavelength natin. Imagine nyo, incident light, dadaan siya sa may glass, then it will be reflected, and then a portion will be transmitted. Yan, reflect, transmitted, reflect, transmitted, reflect, transmitted. Angle is a big factor when it comes to your interference filters. So ito yung tsura niyan, no? So this is your lens. Okay, so you have your glass here, and then you have glass here. Now you have your cavity spacer at the middle. Ito yung dielectric, which reflects the light coming from the light source or the incident. You have your incident light. Yung light source natin, right? So saan gawa yung interference filter? Two pieces of glass that will mirror each other and then separated by a transparent spacer or cavity spacer. Before yung cavity spacer, meron tayong semi-reflective coating which will reflect that incident light. Okay, so two pieces of glass mirroring each other, separated by a transparent spacer that is precisely 1/2 of the desired wavelength. Okay, so wavelengths that are twice the space between the glass surface will be reflected back and forth, reinforcing others of the same wavelength. So, paano natin ma-isolate yung wavelength dito? Sabihin natin, nandiyan na yung incident light. So, dumaan na siya sa may glass. So, portion will be reflected. Portion will be transmitted. Ito yung ating desired wavelength. Okay? Split. Continuous reflect. Okay. And then yung transmitted light, yun na yung desired wavelength natin or yung specific wavelength natin. Yung picture ng interference filter. Side view. Diba? Side view. Okay. Next, you have your... Ay, hindi pa tayo tapos. So, interference filter is composed of your semi-transparent silver films on both sides of the dielectric and will transmit a narrow range of your wavelength. Now, it will require utilization of your accessory cutoff filters. Next type of your monochromator, yung pinakita ko kanina, is you have your prisms. Okay, so prism has the capability to separate white light. See here, white light, pag naman sa prism, into a continuous spectrum by refraction. Okay, so the shorter wavelength will be refracted, while the longer wavelength passes through. And yan. So this is your incident light or the white light which will pass to your prism. This is your, saan yung label nito? Wait lang, class. Punta ko to sa gilid. Ayaw. Ayan. Okay, ito yung exit slit nito natin, diba? So wedge shaped glass quartz. Now the prism, pag ito-turn mo yung knob sa may spectro, it will also rotate. So the prism may be rotated. Pag ni-rotate mo yan, iba rin yung lalabas na isolate na wavelength. Prism may be rotated so that the desired wavelength will pass to your exit slit. This is your exit slit. Itong light na to, ito na yung dadaan sa may cuvette natin or dun sa may sample cell natin. Okay, so that's the principle of your prism. From white light, it will be separated, okay, into a spectrum. Yan. So, paano ma-isolate yung desired wavelength? No? You rotate your prism. So, prism may be rotated so that the desired wavelength will pass through your exit slit. Remember that your exit slit will only let the isolated wavelength to pass through. Okay, next is you have your diffraction gratings. Diffraction gratings. Okay. In diffraction gratings, you have a surface that has parallel grooves etched onto a polished surface. No? So this is the most commonly utilized monochromator. This is the light that comes from the light source. That's your incident light, which will now cross path with your grating. Ito, andito yung groove edge. Okay. This is your polished surface. Then you have your grooves edge so that it will now diffract. Okay, so magkakaroon ng diffraction separating the different spectrum. So you have your diffracted light, you have your red, green, and blue. Tapos ito yung reflected light. So ganito yan. Tingnan natin. So you have your light source here, right? So yun mo yung light source. Dadaan yan sa may diffraction grating, separating now the different wavelengths. Kita nyo? Diba? So, pwede mong i-move din yung diffraction grating para ma-isolate mo yung desired wavelength. Okay. Okay, so ito yung example. No? You have the light source here. Dumaan siya sa may entrance slit. Dumaan siya sa may surface, polished surface. Ngayon ang nangyari, karoon ng diffraction separating the different wavelengths. So, in-isolate niya dito yung blue light para dumaan sa may solution. Okay, so you can adjust this one. No? Gumagalaw din yung diffraction grating. Actual picture. You have the diffraction grating here, separating now the different wavelengths. Next, of course, we cannot read the absorbance without your sample cell or your cuvette containing now your solution. Okay, so sample cell is also known as your absorptive cells or cuvettes. You can also call it as your analytical cell. Now, for this light path, no, ginawa na siyang constant, standardized na siya, 1 centimeter. Okay, so we can differentiate your sample cell according to the material or pwedeng according to the shape. Punta mo tayo sa according to the material. According to the material, you have your glass and you have your quartz cuvette. Pag glass cuvette, this is used if you're going to measure the absorbance or if you're going to need the visible range only. Okay. Quartz cuvette, this is used pag nagbabasa ka ng absorbance sa may UV range. Okay. According to shape. So I think you have already encountered this different shape of your cuvettes. So you have your round cuvettes, which is difficult to manufacture kasi yung diameter niya, no, hindi mahirap ipantay-pantay. Then meron siyang etch to indicate the position for use. For cuvettes, plain parallel optical surfaces. It has more a constant light path compared to your round cuvette. Round nga kasi, ito naman square, flat surface. Okay, kung saan dadaan yung ilaw. Okay, so square cuvettes are preferred over round cuvettes. Why? Because less error from lens effect, orientation to the spectrophotometer, and less refraction. Okay, next you have your photodetector. If you can remember doon sa ating principle, the photodetector will convert that light energy to your electrical energy. Now, how is that possible? How is that possible na yung photodetector, i-convert niya yung light energy into electrical energy? Okay. So, this is due to your electricity. Okay. If there is a flow of electrons, tandaan natin to, if there's a flow of electrons to a conductor, it will now produce electricity, usually in the form of a wire. So yung conductor natin, pwedeng wire. Yung flow na nire-refer dito is also called as your electric current. So if there is movement of electrons or flow of electrons in a conductor, you will produce now electricity. And then, you have the electrons here, right? So pag may movement ng electrons from the cathode going to your anode, it will now produce electricity. So movement of your electrons, see? Which will now, so you have movement of electrons here, you have a movement of electrons here going the anode, going to your anode, you will now produce your electricity. Ayan. So, tandaan yan para maintindihan natin ang photodetectors. Okay, so we have different types of your photodetectors such as your photocell, phototube, photomultiplier tube, and photodiode. Okay, yung pinaka-basic, you have your photocell. It's also known as your barrier layer cell. So it's composed of a film light-sensitive material. Okay, light-sensitive material. Pwedeng selenium on a plate of iron. Meron din siyang silver covering. So ito yung parts ng ating photocell. No? So you have your electrodes. Diyan dadaan yung electrons natin. You have your ceramic, clear coating over entire top surface, photoconductive material over top surface, and you have your wire terminals. Yung ikakabit sa meter. Okay, tingnan natin kung ano nangyari pag na-expose ang ating photocell sa light. Yan. So you have the transmitted light, nakapunta na siya doon sa may photocell natin. So ano mangyayari? Pag itong surface ng photocell natin, okay, the surface of your photocell, na-expose na doon sa transmitted light, ano mangyayari? The electrons will become excited. So, the photosensitive material will make the electrons excited. So, gagalaw na dyan yung electrons. Okay. Ang sabi natin, if there's a movement of your electrons, it will now produce a current. Right? So, you have the highly conductive silver here. So, na-expose. So, nangyari? Nag-move na yung electrons. Okay. So, movement of electrons results to electromotive force, or you have now your electric current. So, movement of your electrons. Yan. So, nandito na. There will be movement of electrons here dahil na-expose na doon sa transmitted light, yung ating light-sensitive material. And there will be movement of electrons over here. What will be produced? A current measured by your meter. Oh, di ba? Okay. What about phototube? Phototube. Okay, so phototube is similar to your photocell, but your phototube uses outside voltage. Okay, so the cathode in your phototube serves as resistor in the dark but emits electrons when exposed to light. Okay, so electron emitted by the cathode jump over the positively charged anode where they are collected. Ito yung picture ng ating phototube. Yung photosensitive cathode, yan yung ma-expose doon sa ating transmitted light. Okay. Then you have your anode which will receive the electrons. No? So, sa photosensitive cathode natin doon yung electrons. Pag na-excite yan, pupunta yan sa may cathode. Okay. And then, magkakaroon na naman tayo ng flow of electrons which will now produce your electric current which will be read by your meter. Okay. So, photosensitive cathode, pwedeng gawain sa rubidium or lithium. Okay, ito na yung ating phototube. Mukhang spaceship, no? Okay, so ilapit tayo. Ayan, tanggalin natin yung cover. Ayan. Okay. So, this is your cathode. So, dito manggagaling yung electrodes natin papunta dun sa may anode. Your cathode is also known as your emitter. And then, anode is also known as your collector because it will collect the electrons. So, may connection yan sa baba. Tingnan natin. So, ito na yung transmitted light. Na-expose na yung cathode. Okay. So, pag na-expose yung cathode dyan, yung electrons, maging excited, pupunta sila sa may anode. So, dito, meron na naman tayong flow of electrons which will now produce the electric current. Oh. For example, nandito yung cuvette. Nandun yung cuvette sa taas. And then, this is the transmitted light. Okay. Oh, ito na yung cuvette. Ayun pala, oh. Light daan sa may cuvette. Umabot doon sa may ating cathode. And then, there will now be flow of your electrons. If you can remember, yung difference ng phototube doon sa may photocell, okay, ito gumagamit ng outside voltage. Battery outside voltage. Para ma-amplify yung electricity. There will be movement of electrons here. There will be movement of electrons here. And there. What do we have? Electric current that will be read by your meter. Okay. Class yung movement ng electrons depende doon sa na-transmit ng light or gaano ka-intense yung transmitted light. The more intense the light, transmitted light is, the more na electrons ang gagalaw to produce that current. Next, you have your photomultiplier. Okay, so how can you remember this photomultiplier tube? Multiply. Okay, it can detect and amplify radiant energy. Since it can amplify the radiant energy, it is 200 times more sensitive than your phototube. So you have it here. Ito yung top view ng photomultiplier tube nyo. You have your incident light. Okay. Of course, pag na-expose tong diode nyo dito, okay, ma-excite yung electrons, ma-excite yung electrons, ma-excite yung electrons, hanggang makaproduce tayo ng electric current. So, ito yung dinodes natin. Dinode chain. Magkakasunod na dinode chain para mas maraming electrons ang gumalaw or mag-move. So, dinodes is a series of anodes. If dinodes are exposed to your light, it gives off secondary electrons when hit by a single electron. Parang ganito yung principle ng dinode. Ito lang ang dinode, right? So, may na-excite na electron dahil na-expose na yung dinode natin. Electron, pag dumaan sa may dinode, magiging dalawa. So, dodoble. Kaya nga tinawag na photomultiplier tube. Dinodoble yung electrons. So, makita. Ayan, buksan natin. Buksan natin. O, mo. Okay. Dito dadaan yung ating transmitted light. We have your cathode here. Transmitted light. Ano mangyayari? Of course, the electrons will be excited. So, since dadaan sa dinode, it means that padami ng padami yung electron. So, kaya tayo tinawag ng photomultiplier. Tingnan nyo. Electron. O, dalawa. Yung apat. See? Hanggang makarating doon sa anode. Yan. So, transmitted light will pass through your cathode, and then you can see now that the electrons are multiplying as it passes to the series of your dinodes. First, there is movement of your electrons. Electrons here, movement of electrons there, movement of electrons here will result now to your electric current. Again, it depends on the intensity of light doon sa current na mapaproduce. Okay, next is you have your photodiode, also known as your reverse bias positive negative junction diode. In a single array of your photodiode, in the single array, meron tayong 256 to 2048 photodiodes. Okay. The resolution is 1 to 2 nanometers. The problem is with your photodiode is that it is not sensitive as your photomultiplier. Okay, so we are done with the different components, different types of your components of your spectrophotometry. We have also discussed that we have discussed the uses or functions of each component. Tapos na din tayo sa principle. So I hope na natutunan niyo yung marami kayong natutunan. Okay. Now, some of you have already operated your spectrophotometer. Now, I would like to have a review on this one para hindi nyo makalimutan. No? Okay, so how are you going to operate your spectrophotometer? Of course, you need to perform the test first. You're going to perform the procedure. In order for you to determine the concentration of a solution, kailangan meron kang tatlong cuvettes, right? You have your blank cuvette, your standard cuvette, and you have your patient cuvette. Okay. Of course, you will need your reagent. And you also need to incubate. Now, for each cuvette, merong corresponding sample. For example, pag blank, you're going to dispense your distilled water. Pag standard, you're going to dispense your standard reagent. Pag sa patient cuvette naman, you're going to dispense your patient sample. Okay. And then you're going to read the absorbance at a specific wavelength. Okay, so this formula is also based on your Beer's law, wherein absorbance of the unknown divided by the absorbance of the standard multiplied by the concentration of the standard will result to the concentration of the analyte. Okay. Ito yung sa patient, ito yung sa standard cuvette. So, ano natin gagawin yan? So, ito na yung natapos na procedure, babasahin mo na yung absorbance, right? So, first, basahin mo muna si blank. What is the purpose of your blank? So, it will remove the interferences followed by your standard. Oh, you write the data so that i-compute natin yung concentration ng analyte natin. Okay, so mauna si blank. Oh, so that yung data niya. That will be 0.083 followed by your standard 0.720. Then you have your sample which is 0.500. Okay, so pwede natin i-compute yung concentration ng analyte. So una si blank, followed by your standard, and then you have your sample. Okay, so ano ang absorbance of the unknown natin? 0.500 divided by absorbance of the standard cuvette, which is 0.720 multiplied by the concentration of the standard. Sir, saan nakukuha tong concentration ng standard? So it is always given, no? Pwede mo makita yan doon sa sticker ng bottle ng standard reagent, or pwede mo makita doon sa may package insert. Okay, so what will be the concentration of the analyte? Of course, do not forget the unit. So for example, the concentration of the standard is 8. So divide this by that, no? Then multiply. You will have now the concentration of your analyte. Do not forget your unit class. Unit is very important when it comes to the reporting of our result. Ayan. So a simple operation of your single beam spectrophotometer. Okay, so I have a case study for you. So pwedeng 5 minutes siguro na pag-isipan. Okay, so ano ang nangyari dito? Okay, so take a look at this one. You have 10 patients for glucose determination. You're already done with the procedure. All you have to do is to read the absorbance of your cuvettes. Pero nang binasa mo yung absorbance ng cuvettes mo, lahat na absorbance readings mo, either negative or zero. So ano kaya nangyari dito? Okay, so case study. So sige, let's try to find out kung ano yung problema. Okay, sige, 5 minutes nyong pag-isipan kung bakit kaya nangyari ito, no? Diyan pa ba kayo? Hello class, are you still there? Andito pa kayo? Oh, mas umunti pa tayo Oh, tingnan nyo, basahin nyo yung case study natin. Ang daming pasyente niyan, 10. Tapos manual method. Ang gagawin mo na lang, since tapos ka na sa procedure, okay, so since tapos ka na sa procedure, babasahin mo na lang yung absorbance. So tatawagin ko kayo So meron pa tayong 2 minutes. Okay, para pag-isipan kung bakit nangyari to. Isipin mo, matatapos na yung trabaho mo tapos yung absorbance mo 0. Ano nangyari dyan? So you could see it as a baka technical, yan ang bahala, technical, or pwedeng mag-base kayo sa theory. Ayan, kung bakit 0 lahat yung absorbance reading. O paano pag nandyan yung mga pasyente natin, right? Kukunin na yung result nila tapos wala ka pang result. Kasi nga ito, puro 0 yung absorbance. Okay, so tawag tayo. Aha. Okay. So isipin nyo lang kung bakit. Unahin natin si Juan. Si Johanna. Johanna Faith, are you there? Bakit
Yes
kaya
po, Doc.
bakit kaya 0 yung absorbance? Mo 0. Bakit kaya? Ano nangyari diyan? Any guess or any theory kung bakit 0 lahat ng absorbance reading? So mag-call a friend. Sino friend mo dito? What about Joanna? Joanna May. Bakit puro 0 yung absorbance reading natin?
Sir, para sa akin is one. Wrong po yung naiisip na wavelength.
Tama, okey. So, tumama si Joanna. So, dahil siguro, ah, masyadong maraming ginagawa yung medical technologies, nung nagbabasa siya ng absorbance, hindi niya nai-set sa tamang wavelength. So, he or the technologist did not set it to the right wavelength. Therefore, the colored product produced was not able to absorb light. That's why you have a zero absorbance. Very good. Ano pa? Frances. Frances, are you there? Ano pa? Ay, wala si Frances, nahiya yata. Okay, so let me give some possible answers when it comes to this one. So, zero lahat yung absorbance. So, nasabi na yung una kanina, um, incorrect wavelength or the wavelength isolate. Yeah, hindi na iset yung tamang wavelength kaya hindi naka-absorb ng light yung colored product. Another one is you have um, there's a possibility when it comes to your technical, uh, the sample was not dispensed to the reagent. Therefore, there's no chemical reaction that happened. Therefore, there's no production of your colored product. That's why walang nag-absorb ng light kasi walang na-produce na colored product. Next, did you know that the light source is also a consumable of your spectrophotometer? Okay. You have your light source, right? It's also a consumable of your spectrophotometer. Sabihin, there comes some time pwedeng mapundi yung light source. So, pag wala na tayong light source or walang light coming from the light source, of course, walang light na makakaabot dun sa photodetector leading to your zero absorbance. Okay, so nasolve na natin yung case study. Possible causes, wrong wavelength, yung light source natin, or walang nangyaring chemical reaction kasi hindi na ipipet ng technologies yung sample dun sa may reagent, di ba? Ayan. Okay. So, punta na tayo sa next. Did you know that your spectrophotometer, meron siyang mga other types besides the single beam? Yung pinakita ko niya is single beam of light that will pass to the components. Now, we also have your double beam spectrophotometer, wherein you have two beams of light that will pass to the different components. Okay? So, light source. Sir, paano magiging dalawa yung light beam natin? That is possible through the presence of your mirror. So, here you can see now, you have your double beam in space. In the double beam in space spectrophotometer, okay, dala-dalawa yung components mo. So, you have two monochromators. You will also need two cuvettes and detectors. Now, what is the purpose? Bakit nila ginawang double beam yung single beam? Okay. So that the absorbance reading will be read simultaneously. Sabay na mababasa yung absorbance ng sample sa kanyang reference. If you have noticed doon sa may single beam, di ba, inuuna si blank, and then followed by your standard, followed by your patient cuvette. Dito naman, pag double beam, dalawa yung cuvette well, insert mo yung dalawang cuvette doon sa may cuvette well. Okay? So, light source, two monochromators. So, pangit yan. You have your light source here, right? So, the light will be reflected so that it will produce two beams of light which will now pass to your two monochromators. So, the monochromator will isolate the specific wavelength which will pass to your exit slit until it will reach your photodetector. Lalagay mo yan ng dalawang cuvette. So, pwedeng andito yung standard cuvette mo, andito yung patient cuvette. O, di ba? Paano naging dalawa yung beam? To the presence of your mirrors. Then, meron din tayong tinatawag na double beam in time. So, this is double beam in space, and then you have your double beam in time. Compared to your double beam in space, the double beam in time only consists of one monochromator, but a lot of mirrors. And if you can see, before the transmitted light reaches the photodetector, we have a rotating chopper. Yan. Ano to? You have your light source, right? Light source, you have your entrance slit, papas yan sa may monochromator. The monochromator will isolate the specific wavelength. And ito na, madodoble na yung beam dito which will pass to your mirrors. Dalawa. Okay. Yan. So, bakit in time? Kasi magkasunod na babasahin. Compared dun sa double beam in space, simultaneous yung pagbabasa ng absorbance. Pag in time, kailangan mag-rotate yung chopper para mabasa yung absorbance ng isang solution or nung cuvette natin. Okay. So, unang mababasa yung absorbance nitong cuvette na to. And then, the chopper will rotate. So, na mababasa yung absorbance ng cuvette na ito. See? Rotating chopper. First absorbance and then yan. Kaya in time. Kasi merong time para mabasa yung absorbance ng second cuvette natin. Okay. Double beam in space and you have your double beam in time. Okay, we are already done with your spectrophotometer or spectrophotometry. Now let us proceed to your flame emission photometry. Okay, so let's take a look at the principle. Principle is that it measures the amount of light produced or emitted from excitation of electrons or samples by heat energy. Through the application of your heat energy, the electrons in the sample will become excited. And as they proceed to the lower energy level, they will emit a light. Okay. So you have the flame here. The flame will serve as your light source. Okay, we use your flame emission spectrophotometry when we are measuring easily excitable metals such as your sodium, potassium, and lithium. Okay. Although, hindi na siya masyadong ginagamit itong flame emission spectrophotometry. Why? Because we have other instruments that can measure the following. So, meron na tayong ion selective electrode. Ipapakita ko siya mamaya. Okay, so not commonly used as your atomic absorption spectrophotometer. So, flame emission spectrophotometry is not used for majority of metals, especially the metals that are not easily excitable. Okay, components. You have the flame, which will serve as your light source. What is the purpose of your flame besides being a light source? It will break the chemical bonds into atoms. Now, it will now excite the atom so that the atom, as it return to its ground state, it will emit a light. So, ito, tandaan natin to. Pag na-excite ang atom at babalik yan sa ground state, it will emit a light. The emitted light, ito yung aabot dun sa may photodetector natin. Okay. Components. Kita nyo yung mga rectangle dito. Rectangle. That will be your monochromator. So, 3 monochromators in your flame emission spectrophotometry. For each ion being measured, like your sodium, potassium, and lithium, meron siyang designated wavelength. So, transmit radiant energy from specific atoms. And then, sa likod ng ating mga monochromators is you have your 3 photodetectors, which will convert that emitted light from light energy into electrical energy. Generates electrical proportional to the radiant energy emitted by the excited atoms returning to their ground state. So, ito yung buong instrumentation niya. You have the flame here. The sample will be introduced into your chamber hanggang makaabot siya dun sa flame. Pag nakaabot na yung analyte doon sa flame, okay, ma-breakdown siya into atoms and the atoms will become excited. Okay, so dito may aspirate yung sample mo. Then, ma-introduce yung sample doon sa flame. Then, chemical bond, mako-convert siya sa atoms. The atoms will become excited, which will now emit a light. Okay. Tapos aabot sa may monochromator until it will reach your photodetector. Did you know na the color of the flame can change depending on the ion you are measuring. Okay. So for example, if the color of the flame is color red, maybe you are measuring lithium. Okay. The color of the flame is yellow, then you have sodium. If the color of the flame is blue, you have magnesium. And if the color of the flame is violet, you're measuring potassium. Unique kasi for each ion, merong corresponding color ng flame. Okay, so that's your flame emission spectrophotometry. Okay. Excitation of your atoms that will emit a light. Okay. Next, you have your atomic absorption spectrophotometry, or AAS. So let's take a look at the principle. Measures the amount of light absorbed by the element in the sample in neutral atom ground state and dissociated from its chemical bond. So just like your flame emission, okay, i-convert mo na sa atom, okay, para maka-emit ng light. Okay, so atomic absorption spectrophotometry is used to measure concentration by detecting the absorption of light by atoms rather than your molecules. Okay. So basic components, tignan natin isa-isa. Okay, so by the way, these are the elements that can be measured using your atomic absorption spectrophotometer. You have your aluminum, calcium, copper, lead, lithium, magnesium, and you have your zinc. Ang components niya, you have your light source, you have your sample cell. Ito yung monochromator. Okay. Monochromator, and you have your photodetector. Yung photodetector ng atomic absorption spectrophotometer is you have your photomultiplier tube. Okay, so how does it work? The sample will be aspirated into your chamber. Sample in the solution is aspirated into your chamber where it is mixed with air and fuel. Sir, bakit kailangang may halong air and fuel? Because we are dealing with flame. Okay, we are dealing with flame. Now, the aspirated sample, okay, will pass to your mixing baffles. The mixing baffles will separate the fine droplets from your large droplets. Yung mga large droplets, okay, it will be drained. Yung mga fine droplets lang ang makakaabot dun sa ating flame. Okay. The burner is a long, narrow slit to permit a longer path length for absorption of incident radiation. And then, yung molecules, yung mga sa fine droplets, nandun yung molecules, it will be converted into atoms. Now, the atoms will be exposed to the light coming from your light source. Pag na-expose sila dun sa light coming from the light source, they will become excited, emitting a specific wavelength of light, which will reach your monochromator, and then it will reach now your photomultiplier tube. Yung flame, ganda na itsura ng flame, no? So, the burner is a long, narrow slit to permit a longer path of absorption of incident. So, ito yung sample natin. The sample will be aspirated going inside your chamber. Ang makakarating lang sa taas is yung fine droplets. Okay, so what is the light source? The light source of your atomic absorption spectrophotometry is you have your hollow cathode lamp. It's composed of a gas-tight chamber. It's a cylindrical cathode, contains the element of interest. Okay. Then you have your anode. It's also composed of your inert gas such as your helium or argon. Ito ang itsura ng light source ng AAS. Sir, bakit ang dami? Okay. Kasi for each light source, meron siyang designated ion na i-measure. At for example, yung lamp mo, dapat meron yung lamp mo meron siyang nung element na mini-measure mo. So for example, you will try now to measure aluminum. Dapat yung lamp mo meron ding aluminum. Okay, ganun yun. So specific, the lamp is specific to the analyte. Kaya maraming light source. So for example, this hollow cathode lamp is for measuring your aluminum. This hollow cathode lamp is for measuring your copper. Ibig sabihin, meron din siyang copper. This hollow cathode lamp is used for measuring your lead. Ibig sabihin, in your light source, meron ding lead. Or this hollow cathode lamp is used for measuring zinc. Ibig sabihin, itong hollow cathode lamp, dapat meron din siyang zinc. Okay. So, have your sample. Now, the sample, pupunta yan dun sa may flame. Okay. So, the sample, aspirated, and then it will be sprayed into the chamber, which will be mixed with air and fuel. Bakit kailangan ulit yung fuel? Because we're dealing with flame. So, this is a picture we're in. You can see now that the technology is aspirating the sample. So, maliit lang yung tubing yan. This is the chamber. What will convert the sample into its spray form? You have your nebulizer. Large droplets will be drained. The baffles will separate the large droplets from your small droplets. Only the small droplets will reach the flame. In the flame, yung molecules i-break down, forming now grounded non-ionized atoms. So flame allows the sample to be vaporized, to be in atomic vaporized state. So yun yung flame natin. And then, atoms will be exposed to the light coming from your hollow cathode lamp. And pag na-expose na yung excited atoms doon sa light coming from your hollow cathode lamp, they'll become excited, and as they return to their ground state, these atoms will emit the same energy as it absorbed, which will now reach your monochromator, which will now reach your photodetector. Yung chopper, it's located between the light source and the flame, enables differentiation of your light beam. Okay, so light from your hollow cathode lamp and light from the excited atoms in the flame. Ang purpose ng chopper natin is that para hindi umabot sa monochromator yung light na inimit ng hollow cathode lamp. Ang abot lang dapat na light doon sa ating monochromator is you have your light emitted by the atoms returning to their ground state. Next, you have your photodetector. Okay. Since yung light na ma-measure is galing doon sa atoms na magre-return sa ground state, we will need your photomultiplier tube to amplify the light. Ayan. So, gusto nyo na makita yung chamber? Gentlemen, I would like to introduce to you the chamber. Okay. So, andito yung nebulizer natin, nandito yung oxidant, nandito yung fuel. Okay. So, ito yung baffles. The baffles will separate the large droplets from your small droplets or fine droplets. Okay, let's say we'll now aspirate the sample. Okay. Your sample. Aspirate. Then the nebulizer will convert it into its spray form. O, diba? Can you see the spray? Paano yung tunog nan? Okay, then it will be mixed with your fuel and oxidant, which will now reach your baffles. Now, the baffles will separate the large droplets. The large droplets, hindi na siya pwede pumasok dun sa flame. It will be drained. Large droplets. Yan. So, yung large droplets, hindi siya pwede pumunta sa flame. The fine droplets, see, that's fine droplets. These fine droplets will reach the flame. So, anong kulang na lang natin dito? Based sa diagram. Meron tayong fuel, you have your oxidant, you have your nebulizer, you have your burner head. Anong kulang natin? Sige nga, answer kayo. Tatawag ako. Di na bali, makikita niyo yung sagot. Okay, so, kulang na lang yung flame natin. So, fine droplets will reach the flame. Flame. Close-up view. Ayan. Okay. Fine droplets will reach the flame. Now, the molecules in your fine droplets will be broken down into your atoms. So, from molecules to atoms. And then, have your hollow cathode lamp, which will emit a light. Meron din yung chopper dito. There's a chopper here. Okay. So, it will emit a light that will pass through the flame. Okay. As remember, when the atoms are exposed to the light, they will become excited. Okay, so you have your atoms here. Now they will become excited if they're exposed to the light. So they'll get excited. Now as they return to their ground state or unexcited state, they will emit a photon. Nakalimutan yan. Atom exposed to light will become excited. As they return to their ground state, they will emit a photon. Oh. So exposed na yung mga atoms dito, right? So these are the atoms. They're exposed to light. Now they will become excited, and as they return to their ground state, they will emit a photon. Eating it. Okay. Now yung mga photon na emit, yun yung aabot sa may, you have a mirror here, which will be reflected to your diffraction grating, your monochromator, which will now reach your photomultiplier tube. Then you will have your reading. Okay. Ayan. So, simple principle of your atomic absorption spectrophotometry. So, I hope you have understand this one. No? Ayan. Tatandaan nyo dito, kailangan yung molecules ma-convert sa atom. Tapos yung atoms ma-expose doon sa light coming from your hollow cathode. They will become excited. They will emit a light or a photon which will reach your monochromator, your diffraction grating, tapos abot sa may photomultiplier tube. There you go. Okay, next is you have your nephelometry and turbidimetry. So these two are somehow similar. Makikita nyo mamaya. So nephelometry and turbidimetry used to measure concentrations of large particles. Example of which is you have your serum proteins such as prealbumin or the antigen and antibody complexes. Tapos na ba kayo sa immunology and serology? Okay, so antigen, tapos na kayo dun, di ba? Antigen and antibody complexes. Okay. Which cannot be measured by absorption spectroscopy. Okay, nephelometry and turbidimetry used to measure concentration of large particles. Muna tayo sa nephelometer. Okay, so measures the concentration of substance by the means of your light scattering. Okay, so detects light that is scattered at various angles of suspended particles. So measurement of intensity of light, scattered light as a function of concentration of the suspended particles. The more light scattering, no, it basically means na mas maraming particle doon sa may solution natin. Okay, so ano yung mga components ng ating nephelometer? Okay. You have your light source, then you have your lens. Okay. Filter, para tama yung wavelength natin. It will pass to your cuvette. So, less particles, less light scatter. Para yung mga ating mga phototube, no? Ito yung mga phototube natin, which will now detect this scattered light. So, less particles doon sa ating sample, ibig sabihin, less light scatter. Okay. So, more particles, ibig sabihin, more light scatter. Okay, so, we have different types of light scattering, by the way. Yan. Light source, lens, filter. Pag mas marami yung particles natin, mas maraming light scatter. O, di ba? Which will be detected by your photodetector. Now, the placement of your detectors is placed strategically. So, mayroon nakalagay doon sa 15-degree angle saka doon sa 90-degree angle. Okay. Next, turbidimetry measures a reduction in light transmission. Okay. Paano nagkakaroon ng reduction? Okay, so paano nare-reduce yung transmitted light? Due to the formation of your or due to the presence of your particles. Thus, it detects a small decrease in a large signal. So, parang sa nephelometer din lang. Pero yung detector natin, diretso. Andito siya mismo. So if there is less particles in the solution, then less light reduction. Tingnan nyo, yung intensity ng light dito, mas malakas kasi konti lang yung kanyang reduction. Why? Kasi nga, konti lang yung particles doon sa may solution natin. Halos di mo nga makita yung detector eh. Pero pag mas maraming particles doon sa may solution natin, then more light reduction. O, di mo? Less yung intensity ng light compared doon sa kaninang unti. Di ba? Ito, konti lang kasi yung particle, kaya mas intense. Ito naman, since mas marami yung particles doon sa may solution, bawasan o nagkaroon tayo ng reduction. Okay. And so that's your nephelometry and turbidimetry. So photometers or spectrophotometers are often used as turbidimeters. As turbidimetric measurements are easily performed on them and require a little optimization. Okay. The instrumentation for nephelometry and turbidimetry is similar, only the difference is with the detectors. Diba yung pinakita ko kanina, iba yung placement ng detector sa nephelometer. Meron tayong detector na nakalocate sa 90-degree angle and another one is you have your 15-degree angle. Okay, so instrumentation, components na nakita nyo kanina, you have the light source that could be your tungsten lamp or white light for your nephelometers. And then you have your filters for your turbidimetry. Okay, so blue filter for 530 nanometers. Pag nephelometer, you will only need the visible filter. Okay, of course, nakita nyo dun, di ba? Meron din tayo yung sample cell or yung cuvette. And then you have your detectors, phototube. So, ano yung mga light source natin for nephelometry and turbidimetry? You have your tungsten. Okay. Then you have your monochromator, the sample holder or the cuvette. You have your phototube. Okay. Ito yung ating photodetector. Okay. So, anong gagamitin natin? Are we going to use the nephelometry or turbidimetry? That depends upon the amount of light scattered by suspended particles present in the solution. Turbidimetry is used for high concentrated suspensions while nephelometry is used for low concentrated suspensions. That's it. Okay. Tabulated differences between your nephelometer and turbidimeter. Okay. Oh, scattered light pag nephelometer. Pag turbidimeter, light passing to a medium with dispersed particles. Instrument use, nephelometry machine, spectrophotometers as turbidimetry. Type of light measured, scattered light. Pag turbidimeter, transmitted light. Arrangement, right angle, 90-degree angle, 50-degree angle. Location of your photometer. Pag turbidimeter, same in the same direction as the propagation of light from the source. Clinical uses, nephelometer, antigen antibody reaction, immunocomplex reaction, no? And then you have your proteins and lipoproteins. Pag turbidimeter, antigen antibody reaction, immunocomplex, proteins, to assess the liver function, no? Or protein in the urine or CSF. Okay, so we are done with your turbidimetry and nephelometry. Punta naman tayo sa reflectance photometry. Reflectance photometry, the intensity of light or the reflected light from the reagent carrier is compared with the intensity of light reflected from a reflectance or surface or reference surface. Okay. Components of your reflectance photometry, of course, you will need your lamp, the slit, the wavelength selector or monochromator, which will now pass to your lens. And then you have your test surface. Okay. So, ang i-measure dito is yung light na na-reflect nung test surface. Okay, so the lamp generates a light which passes through the filter and then a series of slits or lens and is focused on the test surface. So, yung light pupunta sa may test surface. Okay. And then, ano mini-measure? Ano yung aabot sa photodetector? Yung na-reflect na light. Okay, so similar with your photometry, some light will be absorbed by the filter, The remaining light, however, is reflected. Then the light reflected is analogous to the light transmitted in your photometry. The reflected light passes through a series of slits and lenses until it reaches the photodetector, where the amount of light is measured and recorded as a signal. Okay. But the intensity of the reflected light is nonlinear in the relation. Okay, so hindi linear. That's why you're going to use your Kovalka-Monk equation or the Clapper-Williams para maging linear. Okay, yung result. Okay, so tapos na tayo sa photometric. Let us now proceed to your luminescence. So the first one is you have your fluorometry, fluoresce. Okay, fluorometry, measurement of emitted fluorescence light. Okay, we need to define the following terms. When you say fluorescence, the molecule that absorb light at one wavelength and it will emit another light at a longer wavelength. You call this as your Stokes shift. Makikita nyo ito mamaya. Fluorophore. This is an atom or molecule that has the ability to fluoresce. Okay. Fluorometry, measurement of emitted fluorescence light. Fluorometric analysis, very sensitive and widely used method, works under the principle of your fluorescence. Basic concepts. Molecules of a certain substance have the ability to absorb radiant energy. Tulad nung pinakita ko kanina dun sa may AAS, di ba? Yung atoms have the ability to absorb radiant energy or light energy. So, molecules, ganun din. No? Molecules of a certain substance have the ability to absorb radiant energy. Okay. Now, the compound having absorbed a photon of light from the light source is now at a higher energy level. Okay. So, yung molecule mo, pag naka-absorb ng light at a specific wavelength, okay, magiging excited at nasa higher energy level na siya. Okay. The light source, you call that your excitation lamp. It will excite the molecule. No? Now, the compound will now return to its lower level of energy in a very short time. So, saglit lang siya naging excited. Okay. Now, as it returned to its ground state, the energy being emitted as a visible light or light of a longer wavelength than the excitation light. We call it yung Stokes shift. Diba? Shorter wavelength yung nagpa-excite doon sa molecule. Nung na-excite siya and as it returns to its ground state, okay, ang na-emit na light is a longer wavelength. Kuha nyo? Yung nagpa-excite sa kanya, sa molecule, shorter wavelength. It become excited, right? So at a very short span of time, as it returns to its ground state, but the emitted light is of longer wavelength. That's your Stokes shift. Now, the substances can be identified by the excitation and emission spectra. Okay? So the intensity of the fluorescent light can be identified by the excitation and emission spectra. Okay? So remember, in fluorometry, or we have two energy states. You have your ground state and you have your excited state. So based on the energy exchange process, the molecule or the substance will absorb your light or your electromagnetic radiation, will become excited, and then it will return to its energy level lower than or equal to their original level. Yung time. So, sobrang bilis. 10 raised to negative 15. Maging excited, 10 raised to negative 5. So, 10 raised to negative 14 to 10 raised to negative 12 seconds. Okay. So, the excited state lasts about 10 raised to negative 5 before the electron loses energy and returns to its ground state or return to the lowest excited state. How will they lose the energy? Now, under the principle of fluorometry, para ma-lose yung energy, there will be emission of your radiant energy. Ito na yung mini-measure natin sa fluorometry. Okay, punta tayo sa instrumentation. So, this is your excitation lamp. The purpose of this excitation lamp is to make the molecules in the sample excited. Kaya nga, tinawag na excitation lamp. So, what did you notice besides this excitation lamp? In your fluorometry, meron tayong dalawang filters. Okay. Did you notice that you have two filters? Okay. Yung lamp pala na ginagamit dito is you have your mercury vapor lamp, which gives a mixture of UV light and visible light, or you can also use your xenon lamp. Okay, punta muna tayo sa excitation lamp. So it will emit a specific wavelength of light. Itong oval dito. Okay, this is what you call your collimating convex lens, which collects the light from the light source. Then you have your filter. Primary filter absorb the visible light and only allows the visible light to pass through. Then we have another lens here, allows the filtered radiation to focus on the sample cell. Okay, so here, imagine yung nangyayari, di ba? The molecules will become excited. Okay, so mabilis lang yan. They will become excited and they will return to their ground state or lower than their ground state. As they return to their ground state, they will emit a light of a longer wavelength, which will now then be collected by your which will be collected by your lens, but the lens is located 90 degree to the incident light. Then you have your secondary filter. This will filter the light coming from this lens or by the emission filter. So the emission filter just filter the UV light and only allow the visible light to pass through. Then we have another lens here. The lens collect light from the emission filter and focuses onto the detector. Yan. Makarating siya doon sa may photomultiplier tube natin. Light source will emit a shorter wavelength which will excite molecules, high energy excitation light. So pwedeng gas discharge, mercury, or xenon. Next, the primary filter, this one, selects the wavelength that is best absorbed by the solution to be measured. Secondary filter passes longer wavelength of fluorescent light to the detector. Prevents incident light from striking the detector. Then your photodetector, pwede siyang phototube or photomultiplier tube. You might be wondering, Sir, bakit hindi diretso na lang? Bakit hindi nandito yung photomultiplier tube natin? Why do you think so? Bakit nakalagay siya doon sa 90-degree angle? Okay, the reason for that is, syempre, nandito yung excitation lamp mo. Ngayon, kung nandito yung photodetector mo, there's a possibility na maka-absorb or makakuha din siya ng light coming from your excitation light. Na dapat ang makukuha niya lang na light is the light emitted by your excited molecules returning to their ground state. So, gets nyo na kung bakit nakalagay dito yung photomultiplier tube natin at hindi dito. Kasi pag nandito, makakuha siya ng light coming from your excitation lamp. Okay, next is you have your chemiluminescence. Principle, the chemical reaction yields an electronically excited compound that emits a light as it returns to its ground state or transfers its energy to another compound which then produces emission. So dito din sa chemiluminescence, okay, you have excited compound. Now as it returns to its ground state, it will again emit a light. So from excited to your lower energy level, okay, emission of light is created from a chemical or electrochemical reaction and not from absorption of electromagnetic energy. Okay, principle. Chemiluminescence will occur if there is oxidation reaction, then production of chemical energy, production of your excited intermediates. The intermediates decay to a ground state, then emission of photons, resulting to emitted radiation measured by a photomultiplier tube. Okay, so we will need chemiluminescent reactions so that it will emit a light by a chemical trigger. So the emitted radiation is measured by your photomultiplier tube. Okay, so the signal is related to the analyte concentration. Kung mas marami or mas mataas yung signal, ibig sabihin mas maraming analyte doon sa sample natin. So how does chemiluminescence differ from your fluorescence? Compared to your fluorescence, yung fluorescence kasi meron siyang excitation lamp. No? Dito sa chemiluminescence, no excitation radiation, no monochromators. So these are the different agents for your oxidation reactions: luminol, isoluminol, acridinium esters, luciferin, hydrogen peroxide, hypochlorite, oxygen dioxetane. Okay. Ito naman yung stats natin. You have your hydrogen peroxide, hypochlorite, and oxygen. Chemiluminescent reactions can be enhanced by the presence of your catalysts, such as your enzymes like alkaline phosphatase, horseradish peroxidase, microperoxidase. Then you have your metal ions, such as your copper and iron. Pwede rin yung hemine. Okay, instrument. Meron kang luminometer, photomultiplier tube, and the emitted radiation. So, chemiluminescence. Now, the sample for your chemiluminescence, may ilalagay siya sa column. Tapos nandito yung luminescent reagent mo. The luminescent reagent will be delivered into the mixture through your delivery pump. So, dito magmi-mix yung analyte mo na nanggaling sa column at saka yung luminescence reagent mo. And then, a chemiluminescence will occur. Now, the light emitted will be detected by your photomultiplier tube. Ganyan siya. So, nandito yung analyte mo. Your analyte is over here. Your luminescent reagent is over here. Okay. Yung analyte mo sa column. That's your analyte, right? So, nakalagay siya sa adsorbent stationary phase. You will need your eluent para lumabas yung analyte dito sa may column mo. Call that elution. So, papasok yung eluent, right? So, lalabas yung analyte. Okay. So, from eluent, magiging eluate na siya. So, eluent, tama na yung analyte naging eluate. Now reach your mixer. By sa luminescence reagent, because we will need this in order for the chemiluminescence to occur. The chemiluminescent reagent will be delivered by your delivery pump. Dito na sila maghahalo. Okay. Reactant A plus reactant B will result to a chemiluminescence. Yan. Tapos yung emitted light will be detected by your photomultiplier tube. And then, will be measured by your luminometer. Gets nyo? Simple lang, di ba? Ulitin natin. Okay, you have your column. Nandito yung analyte mo. Kailangan lumabas ng analyte doon. So, you will need your eluent. So, you call this process elution. Eluent. Oh, ba't nandiyan na kagad? Analyte mo lumabas na, right? And then, nandan siya dito sa eluent. From eluent, magiging eluate. Tapos, sa mixer. Tapos, yung luminescent reagent, may di-deliver using your delivery pump. Mataas yan. Mataas. And then, dito sila maghalo. Reactant A, plus reactant B, chemiluminescence. Yan. So, product plus type. Have your by your photomultiplier tube, measured by your luminometer. Okay, advantages of your chemiluminescence. Ultra-sensitive. Speed. Kasi nga, flash type reaction, light is only measured for 10 seconds. Very easy to use and a simple instrumentation. Disadvantages, pag doon sa may luminescent reagent mo or doon sa sample mo, merong impurities, may cause background signal that degrades sensitivity and specificity. Where do we use your chemiluminescence? Automated immunoassay, DNA probe, assay systems. Okay, so we are done with your luminescence. So, ano yung luminescence? Nandun si chemiluminescence, saka si fluorometry or fluorescence. Now, let us deal with electricity a little bit. So, you have your electrochemistry. Okay, electrochemistry. Okay, so electrochemistry is a branch of chemistry that deals with the relationship of electricity and chemicals. Okay, so the first one is you have potentiometry. our potentiometry, you will need 2 electrodes, and for you to measure the concentration of the analyte, you need to get the difference between these 2 electrodes. Now, what are the electrodes in your potentiometry? The first one is you have your reference electrode. So this reference electrode is constant and completely insensitive to the composition of the solution under the study. So, ano yung mga commonly used reference electrode natin? You have your calomel, or also known as your mercury, mercurous chloride, and you have your silver, silver chloride. Calomel, or the mercury, okay, mercury, mercurous chloride, okay, in direct contact with the mercury in a solution of your potassium chloride. Okay. The problem with this electrode is that it is slow and unstable at above 80 degrees Celsius. You have your silver, silver chloride, silver wire rod, or rod coated with silver chloride solid immersed in a chloride solution. So you could use this as an internal reference element in ion selective electrodes and external reference electrode half cell of constant potential. Silver, silver chloride coated silver wire. Advantages, no, compared dun sa calomel, more compact electrode than mercury, stable up to 275 degrees Celsius. Okay, so sabi dun sa potentiometry, it will require 2 electrodes, right? Next, you have your measuring electrode or the indicator electrode. This is sensitive to your hydrogen ions. Okay, so concentration of ions in a solution can be calculated from the measured potential difference between the 2 electrodes. Yan. So how is the concentration of the ion sample determined? Calculated by the measure the potential difference between 2 electrodes. Sample of an instrument that works under the principle of potentiometry is you have your ion selective electrode. Baka na-handle nyo na to doon sa rotation nyo sa internship. So it is an electrochemical transducer able to respond to a given ion. This type of instrument is very sensitive and selective in measuring ions. Okay. For each analyte, merong designated electrode. If you're going to measure the pH, you have your glass membrane. If you're going to measure sodium in your sample, you will need your glass aluminum silicate. Then, sa potassium naman, kailangan yung valinomycin gel. Ito, sino naka-operate nito nung nag-rotate kayo or nag-rotate kayo sa clinical chemistry? This is your easy light. Okay, so pag titignan mo yung loob niyan, nandun nakalagay yung mga electrodes natin. Let us operate the easy light analyzer. Okay, so merong dalawang buttons doon. Pipindutin mo lang is yes or no. Now, this machine is always asking you. No? So, analyze blood. No? So, you're going to press yes, right? Yes. And then, bababa yung probe. Tapos, lalagay mo yung sample. Tapos, tatanungin ka ulit, probe in blood. And of course, you're going to press yes again. See? Yes. Then, it will aspirate the sample to the tubings. Dadaan yun sa electrodes. And then, the analysis will start. After the analysis, mag-display na yung result. Ganun lang siya kabilis. Diba? Kabilis. Yes. Probe in blood. Yes. Aspirating. Analyzing. Then the result will be displayed. So, oh. Ito mo? Andyan na yung probe, oh. Press yes. You can see now. Wait lang. Mas maganda pag sa simula. Okay. So, press yes. Tapos, bababa yung probe. Okay. Then, pagbaba ng probe, lagay mo yung sample. And then, the sample will be aspirated. Okay. So, press yes again. Yes. Tapos, ma-aspirate na yung sample. Dadaan na siya dun sa may mga electrodes natin. Then, you're just going to wait for it. Wait for it, wait for it. Then you have now the result. Okay. And then, itong instrument na to, ipiprint niya pa yung result mo. Okay. Baka na-operate nyo na to sa hospital. Ayan. Okay. Next, still under the electrochemical, you have your coulometry. Coulometry measures the quantity of electricity in coulombs. So the unit will be in coulombs needed to convert an analyte to different oxidation states. So number of silver ions released by ionization, which will be equal to the chloride of ions in the sample. Okay. So you could use your serum, plasma, CSF, and sweat samples. Next, you have your amperometry, measurement of the current flow produced by an oxidation reduction reaction. So the change in current, is measured to the cell, and the change is directly proportional to the partial pressure of the oxygen present in the specimen. Have your voltammetry. Potential is applied on electrochemical cell and resulting current is measured. So these are the different applications of your electrochemical methods. For potentiometry, you could use it for the measurement of your PCO2, sodium, calcium, potassium, ammonia, and pH. Amperometry for measurement of your PO2, glucose peroxidase. Coulometry, measurement of your chloride. Voltammetry, anodic stripping voltammetry. Still under your electrochemical, you have your electrophoresis. Okay, mas makaka-relate kayo dito. So it is the movement of electrically charged compound in a medium resulting to their separation based on their electrical charges when an electric current is applied. So one purpose of your electrophoresis is to separate the different molecules or substances based on the electrical charges when an electrical current is applied. So do not forget this acronym, PANIC. The positively charged molecules will go towards the anode, the negatively charged will go towards the cathode. So ions move towards their opposite electrodes. Remember that the biologic molecules are charged ions. Now their movement or their mobility will depend on the pH. Okay. So their charge depends on the pH of the medium. Usually 8.6 is used, especially for the serum protein electrophoresis. No? So at pH 8.6, proteins are negatively charged and they move towards the anode. Different components of your electrophoresis. Of course, you will need your electrophoretic chamber, okay, your electrodes, diffusion barriers. Yan. So ito yung electrophoretic chamber natin. Of course, you will need your power supply. Kasi pag walang current, walang mangyayaring electrophoretic mobility. Buffers will help maintain the pH. So allow the current to be carried through the sample, okay, without changes in the overall solution. So you will need high quality buffers. It's an important part of your electrophoresis. Buffer solution must have a controlled ionic strength and does not allow good separation of your fractions. Of course, kailangan mo ng current. That's why you will need your power supply. Okay, so electrophoresis needs high voltages ranging from 50 to 200 volts. And you have your electrophoretic gel. So dito mangyayari yung electrophoretic mobility. It could be cellulose or agarose. So the samples are placed onto your support medium like your cellulose acetate, agarose, and polyacrylamide gels. For you to see the electrophoretic pattern more clearly, you will also need dyes such as your Amido Black, Poncho S, Fast Red, and Sudan Black B. Okay, sabihin natin in-on na natin yung electrophoretic machine. So there will now be migration of your different molecules or substances depending on their charge. So it's pH is a very important factor when it comes to your mobility. Diba? So you can see now that there will be migration. No? So pag nagkaroon na ng migration, you can see now the bands. Okay? You can see now that they are separated from each other, or the substances are separated from each other. Okay, so in electrophoresis, staining is very important so that you can visualize different protein fractions. But if you want a more accurate quantification, then gamit ka ng densitometry. So the gel is moved past a measuring optical system and the absorbance of each fraction is displayed on a recorder chart or on an electronic display. So you have your chromatography. Okay. Chromatography, okay, separation of complex mixtures on the basis of different physical attractions between the individual compounds and the stationary phase of the system. Yung electrophoresis, it can also separate but depending on the charge. Pag sa chromatography, it can separate based on the different physical attractions. Okay. So, ano bang components ng chromatography natin? You have your mobile phase, which carries the complex mixture, stationary phase, substance through which the mobile phase flows, and you have your column. It will hold the stationary phase. Then you have your elevate. Ito na yung separated components natin. Okay, so you have the sample here. You have your stationary phase, okay, which will now carry the complex mixture. Okay, your column. We can see here that in the picture, after ng chromatography, na-separate na yung mga different chemicals natin. Ayan. Column, see? Bit by bit, as they move, no, nasi-separate sila. Okay. Okay, so we are done with your automation. We are done with your instrumentation. Okay. We will now proceed with your automation. Okay, so sino dito, before tayo mag-proceed, sino dito ang naka-try na mag-operate ng ating automated machine? Anyone from the class, would you like to share your experiences? Pampagising lang. Wala. Sino naka-operate or naka-maintain, nag-maintain ng automated machine? Anyone? Wala. Okay. Wala nag-try. Okay, anyway. Okay, so if I hear the word automation, ang pumapasok kagad sa isip ko is that automation makes our lives easier as professionals. So it has several advantages. Why? Your automated analyzers can perform many tests, okay, with only minimal involvement of the analyst. All you have to do is to input the data of the patient, highlight the test in the software or in the panel. Okay. By the way, it is a controlled operation of the apparatus. Okay. Okay, so mechanical or electronic without human intervention. Okay, so the system is mechanical or electronic without human intervention. So that's automation. Okay. To define the following terms, when you say throughput, this is the number of specimens processed by an analyzer during a given period of time or the rate at which an analytical system processes specimen. When you will try to purchase this automated machine, try to look at the throughput. Okay, pag high throughput, ibig sabihin, kaya niya mag-process ng maraming specimen. Next, batch analysis. Samples are loaded at the same time and a single test is conducted on each sample. Pakita ko ulit yung slide kanina na pinakita ko. Your controls, right? Okay. So yung controls ilalagay mo doon sa designated placing niya. If you have noticed, andito na yung mga pasyente. Okay. So sabay-sabay mong niload yung pasyente doon sa ating sample vessel. Okay, because we're going to perform batch analysis. Okay. Continuous flow. Itong continuous flow na to. This is a type of analysis in which each specimen in a batch passes through the same continuous stream at the same rate and is subjected to the same analytical reactions. If you will see an analyzer that has a lot of tubings, then more likely na continuous flow yun. Okay. So that's your continuous flow. You have the sample, will be aspirated by the tubing. Sir, paano yan? Iisa lang yung tubing. Ang daming samples ang i-aspirate mo. Now, the samples will be separated by your bubbles. Okay, so for each sample, sa gitna nila, merong bubbles. which will now pass to your tubing until it will reach now the chamber wherein it will meet with the reagent. Tapos diretso sa incubator, then diretso sa reaction detector. Okay. Ito, you have your sample here. May tubing para sa sample. May tubing para sa may reagent. The sample will be aspirated through this tubing. This reagent will be aspirated through this tubing, and then magmimix sila sa chamber na ito. And then another reagent makikipag-mix sa chamber na ito until it will reach the incubator. Tapos dito na mangyayari yung photometric measurement natin. That's why your continuous flow. Discrete analyzers. Okay. Samples flow through a common reaction vessel or pathway. One distinct trait of a discrete analyzer is that it has a probe. Then meron din siyang reaction cup or another container. Okay. So this is a type of analysis in which the sample is aspirated into the sample probe and then is delivered often with the reagent to the same orifice into a reaction cup or another container. Excuse me, class. Okay, balik tayo. Okay, so that's your discrete analyzer. Okay. How would you know that the analyzer is a discrete analyzer? It has vessels. It has a vessel for your reagents. It has a vessel for your samples. And you can see now that there's a probe. The probe is like the substitute of your pipetting in the manual procedure. The probe is the one now aspirating your reagent and your sample, dispensing it into a common vessel or a common reaction cup. Yan. Ito yung machine namin sa clinical lab. Okay, you can see now that it has several vessels. You have your sample vessel, reagent vessel, and then itong vessel na to, dito nakalagay yung mga cuvettes. So, dito i-dispense yung reagent at saka yung sample. Okay. Sample vessel, nakalagay yung patient samples. Dito naman, reagent vessel, nakalagay yung reagents. Okay. Then ito, dito yung mga cuvettes. Diyan, i-dispense yung mga reagent and sample na na-dispense. Okay. So, might be wondering, iis lang yung probe, right? It only has designated probe for reagent and then designated probe for your samples. So, hindi ba kaya mag-contaminate, mag-cause ng contamination? O may tinatawag tayo na carry over. So, wherein the transport of quantity of an analyte or reagent from a one specimen reaction into and contaminating a subsequent one. Now, to avoid this carryover, before the probe will aspirate another reagent or another sample, it will be washed. Okay? Mawawash muna dito sa part na to before mag-aspirate ng bagong reagent or bagong sample or ibang reagent or ibang sample to avoid your carryover. Okay? Then you can see dito sa cuvettes natin, you can see that ito yung wash unit or it's the one now washing our cuvettes after the reading of your absorbance. Under this vessel, merong heating block, okay, which will serve as the incubator. So may heating block yan sa baba just in case kailangan ng test ng incubation. Tapos sa baba nandun na rin yung ating photo detector, nasa baba na rin yung lamp, okay, for the absorbance reading. Mhm. Okay, ano 'tong parallel analysis? More than one test is analyzed concurrently on a given clinical specimen. Paano 'to? So, tingnan niyo 'to. These are the tests. 'Pag kaya niya yung machine mo kaya mag-perform ng parallel analysis, so puwede mong i-highlight yung mga kailangan mong test. So, for example, 'yan, 'yan, highlight mo, highlight mo. See? That's your parallel analysis. Okay. Random access, any test may be performed in any sample in any sequence. Tingnan niyo 'tong panel na 'to. So, for each patient, iba-iba sila ng test, right? So, this patient, ang request niya is lipid profile, okay, inner hearts, total protein, and albumin. Ito, another patient, ang pina-test niya is BUN creatinine. So, for each patient, puwedeng different yung test na i-request. Sequential, multiple tests are analyzed one after another on a given specimen. Okay, so for example, you have a lot of patient samples. Okay, so ang gagawin ng sequential analysis is that unahin niyo munang i-test yung glucose ng lahat ng sample, followed by your cholesterol, for example, followed by your BUN. Okay. Single channel, a type of analysis in which each specimen is subjected to a single process so that the results of a single analyte are produced, similar to your batch analysis. Okay, so that's your automation. So to summarize your automation, we have your discrete and you have your continuous flow. So for each analyzer, merong unique trait. Like for example, for discrete analyzer, you have your probe. Okay, you have your vessels, sample vessel, you have your reagent vessel, you have your reaction vessel. Pag sa continuous flow naman, sequence of tubings, the samples and reagents does not mix kasi nga it is separated by your bubbles. Sorry. Okay, class. Now let us proceed now with the next one. Tapos na tayo sa automation. Let us proceed to your point of care testing. Point of care. So our objective for this part of our seminar is to learn the importance of your point of care testing, differentiate the different POCT methods, their advantages, and when are you going to implement POCT, and what are the different POCT methods. So point of care testing. Okay. In many institutions, laboratory testing, okay, laboratory testing has been pushed out to point of care testing. Okay. Now, with the presence of your point of care testing, it will shorten the turnaround time for critical results and enhance convenience for both patients and caregivers. Okay. So, point of care testing is a method for clinical laboratory testing in which the analysis is performed at the site close to where the healthcare is provided to the patient. So, you can perform this point of care testing near the patient. Sure. Okay. Look at the picture. So, point of care testing. Other terms, bedside testing, near patient testing, physician's office, extra laboratory, decentralized, off-site, ancillary, alternative site, unit use testing. Okay. And what is point of care testing? Okay. So, without point of care testing, the process is much more longer. So, you have the patient here, right? Okay. And then, pupunta siya sa physician. And then, management, diagnosis, Okay, so mas testing, and then it will take time para mabigyan ng treatment or proper management yung patient. But with POCT, okay, shorter turnaround time with your POCT device, okay, less time para doon sa processing and testing para mas mabilis ma-diagnose or ma-treat yung patient. Okay. So, here. Yung conventional testing procedure, if we're going to look at it, it's a long process starting from triage, sample collection, processing of samples, performing of tests, compile test results, and then analyze the test results. Then the patient is admitted or discharged. But with your POCT, all you have to do is to collect the sample, a minimum volume of the sample, load the sample in your POCT device, analyze the result, and release the result. So can you see now that there will be more time saved with the use of your POCT? Okay. So where can you employ your point of care testing? Okay, so primary care, home, pharmacies, clinics, physician's office, diagnostic and treatment centers, paramedical support vehicles. So pwede ka rin mag-point of care sa ambulance, helicopter, aircraft. Sa secondary care, ER, admission unit, operating room, ambulatory diagnostic and treatment center, intensive care unit, ward, and outpatient clinic. Okay. Oh, yan. POCT will decrease the turnaround time of the test. Okay. So in some cases, total cost can be reduced if the devices eliminate the need for laboratory-based instrumentation, or increased turnaround time leads to shorter hospital stays. Ayan. So, would you implement POCT? No? Ano ba yung mga principle na ginagamit? So, tapos na tayo sa instrumentation. What this POCT works under what principle? So, it could be spectrometry, electroanalytic techniques, pwede rin chromatography, or the others, reflectance, no? Light scattering, immunoturbidimetry, spectrophotometry, fluorescence, and polymerase chain reaction. Okay. Before POCT, okay, can be used, it should undergo a validation. The device should be calibrated. Meron din dapat siyang quality control. Okay. And then the individuals using the POCT device should have a training and proficiency, or the POCT device should undergo proficiency testing. Yan. Okay, so ito yung mga certificates natin for our POCT device. You have your certificate of waiver, certificate of registration, okay, and other certificates. So this is an example certificate wherein approve yung POCT device natin. Okay. Okay. Your POCT device should also be calibrated. So I will show you a video wherein the POCT device is calibrated. Okay. So this is a glucometer. Okay. So meron siyang calibration prior to using. Ayan. Okay, so this is the calibrator solution na ilalagay mo dun sa kit. Ayan. So, pag na-calibrate na siya, iilaw siya. Okay. How to ensure that the POCT is accurate and precise? So, total POCT quality assurance is thus the combination of several QC mechanisms. Okay. So, train your POCT operators. It should be reliable and user-friendly. Okay. It should be validated. Okay. Competency assessment of all individuals involved in POCT. Okay. Quality control testing and monitoring, proficiency testing, and connectivity and barcoding technologies. Okay. What are the advantages and disadvantages of your point of care testing? So, advantages, convenient. Sinabi ko na kanina, reduced turnaround time. Okay. Reduction in clinic visits. Some of these POCT devices can be operated by the patient or the watcher. Okay, doon na sa bahay mismo. So, less yung pag-visit nila sa clinic. Better patient management due to improved visibility, interaction with the patient, decreased manpower, and it will only require a small volume of sample. Disadvantages, more expensive, It also needs maintenance. Okay. Some of the POCT device requires training of the operator. Then analytic, and post-analytic issues are not recognized. Okay. Inter-individual variability in POCT results and difficulty with documentation of test results, billing and regulatory compliance. Okay. Other advantages: improve patient outcome, improve cost overall, not require processing availability to a wider variety of sites. Other disadvantages: proper integration of test results into the patient electronic medical record, managing reagent supply and storage. Okay. Central laboratory test results and POCT results are not always comparable due to differences in specimen types. So do you need your point of care testing? So what questions you need to answer when you want to implement your point of care testing in your laboratory or health facility? Number one is it required in your area? Okay. Expected annual test volume, clinical question being asked when requesting the test, decision, how will it increase the patient satisfaction? Okay. Are the personnel of using the POCT competent? Will change in practice be required? Okay. Can central laboratory deliver the required service? Are available POCT analyzers user friendly? Okay. Meron ba siyang quality control, internal and external? And does the company provide POCT analyzers and agents offer a reliable support service? Which means that if there's a problem with the POCT device, can you have a technical support, right? Okay, types of your point of care testing. First, you have your wave test. Okay, wave test, it only needs your FDA clearance, simple to perform and interpret, accurate, and the result, just in case there's an error, it poses no reasonable risk of harm to the patient and no special training is required. So, example ng POCT natin na wave test is you have your glucometers, right? Oh, natatry nyo rin bang monitor ng glucose ng patient using your glucometer? Right, so you can see here that the patient is performing the test or operating the POCT device. So this is an example of a wave test. Okay. Okay. So you have your moderate complexity. Okay. More difficult to perform, stringent set of requirements, certificate of registration subjected to proficiency testing and on-site inspection. Moderate complexity, the clinical laboratory administers training, proficiency testing, and monitor of your quality control. So in this POCT device, okay, it is operated by a trained personnel. Okay, so if you could notice, it only requires a small amount of arterial blood. So this POCT device is used for measuring the blood gas of the patient. Okay. Okay, so the sample is introduced into the cartridge and the cartridge is inserted into the POCT device. And then you have now the result. See? A very short turnaround time. Next, high complexity, sophisticated instrument. It will require a high degree of interpretation. Now, the operator requires significant skill and decision making, and then acquires certificate of authorizing and accrediting bodies. Okay, so the personnel operating this high complexity POCT device should have a personal education. Formal education. Yung example net. Okay, so may mga additional procedures. Okay. Just like with the other POCT, it will only require a small amount of your sample. Okay. And then, ilalagay na naman dun sa may cartridge. Then, it will be inserted to your POCT device. O, di ba? High tech. Okay, and then you're just going to wait for the result. Okay. Okay, so the test is running, and then just wait for approximately 5 minutes, and then you already have the result. Okay. See? So, itong POCT device na to is used for measurement of your lipid profile or for lipid profile testing. Other one, ito. You can see now that the procedure is quite complex. Okay, so you will need your automatic pipette to dispense the sample. So you have the cartridge, ganun din. Then you're going to insert the cartridge into your POCT device. Then all you have to do is wait. So ganyan naka-high-tech ang mga POCT devices natin. All you have to do is to wait for the result. You even have the receipt over here. Ayan. Okay. Characteristics or requirements of your POCT device or analyzer. So ideal reduce errors and enhance patient care, results in a rapid and timely manner, portable instruments with consumable reagent cartridges, capability of performing direct specimen analysis. Okay. So whole blood, hindi mo na kailangan mag-process ng serum or plasma, simple operating procedure, flexible test menus. Okay, so the interface is user-friendly. The result will be accurate and precise, integrated calibration and quality control, ambient storage temperature for reagents, result provided as hard copy, the receipt, no, yung receipt kanina. Results can also be stored is available for transmission, low instrument cost, and built-in regulatory record keeping. So, one goal of your POCT, yung mga nagma-manufacture ng mga POCT device is your miniaturization, no? Especially for the measurement of your electrolytes, blood gas, and other analytes. Okay, so type of technology, single use, qualitative, or semi-quantitative. Ano yung mga pwedeng analyze dyan? You have your urine, blood chemistry, detection of infectious disease agents, cardiac markers, or human chorionic gonadotropin. Meron ding single-use quantitative. So when say quantitative, the result will be in number plus the unit. So glucose, blood chemistry, coagulation, cardiac markers, chlamydia, A1C, urine albumin, pH, blood gases, electrolytes, and metabolites. Then you have your multiple use quantitative cartridge or benchtop devices for the measurement of your hemoglobin, bilirubin, pH, blood gases, electrolytes, metabolites, cardiac markers, drugs, C-reactive protein, and you have your complete blood count. Okay. Okay, so ito high complexity itong test na to. So it will require your skill in using this POCT instrument. Okay. We're going to dispense the sample into your cartridge. Oh, meron pa siyang mixing. Okay, dispense it into your cartridge and all you have to do is wait. Okay, so ilang minutes yon? 15 minutes and your results are ready. Okay. Okay. Next, informatics and point of care testing. So this is according to your CLSI guidelines. So patient information should always accompany the patient test results, which includes your patient sample, operator, device identifiers, date and time of the specimen collection and analysis, what is the type of specimen used, test requested and test result with the appropriate units. And then if there are errors, then there should be error messages and action messages. Okay, so other applications, no, na-mention na ito kanina, glucose, chemistry, blood gases, coagulation, hematology, and point of care connectivity. I have a case analysis here. Tingnan natin. Sam is now 14 years old and has been managing his diabetes effectively. His blood sugar level is within the safe limits. Okay. He's still running for his county and is playing center forward for his local football team. Recently, his glucose meter was replaced with a new one, and since the meter appears to show his blood sugar at consistently dangerous levels, so nagpanic siya, no? Sam still feels fit and well and assures the doctor he still is taking his medication, okay, as well as monitoring his blood sugar daily. So a blood sample taken recently at the hospital showed his blood glucose to be within safe limits. So saan ang mas tamang result? Okay, so if we're going to answer this, mas tama yung result doon sa hospital. Why? Because kung mataas yung blood sugar ng patient natin, it does not correlate with the signs and symptoms. So how would you explain the discrepancy in the result? So since nagpalit siya ng bagong POCT device, baka yung POCT device na hindi pa nakakalibrate, okay, or it's a defective POCT device. Okay, so who do you think should ensure the test performed outside the lab are at an appropriate standard? Okay. So of course, yung mga organizations natin, okay, or yung mga manufacturers natin. Okay. Ayan. Okay, so we are done for this part of your seminar. Okay, so okay, class. So thank you for attending our part 1 seminar. Okay, I hope you will again attend tomorrow. Okay, so tuloy-tuloy yun, no? So no breaks ulit tayo. That's why I can dismiss you early. Okay. Ayan. So, sinong gusto mag-share ng kanilang natutunan? Apat na lang kayo. From 9 naging apat na lang. Yes. Ay, thank you din, ma'am. Thank you po.